Stars aren't just static white dots in the night sky. They're dynamic cosmic light bulbs that change colors throughout their lives. From cool red giants to blazing blue supergiants, let's explore the rainbow palette of stellar evolution. The colors we see in stars tell us a lot about their temperature and age. Hot stars appear blue or white because they give off more blue light waves, while cooler stars look red or orange. Think of it like a piece of metal being heated. It starts glowing red when warm, then turns white hot at higher temperatures. The same principle applies to stars. Our sun, with its yellow-white glow, sits right in the middle at about 10,000 degrees Fahrenheit on its surface. But some stars burn much hotter, reaching up to 40,000 degrees Fahrenheit and shining in brilliant blue. Meanwhile, red giants have cooled down to about 5,000 degrees. These different colors create a beautiful cosmic light show that helps astronomers understand what's happening in distant parts of space. When stars like our sun get old, they go through an amazing growth spurt and become red giants. Imagine our sun swelling up so big it would swallow Mercury, Venus, and possibly even Earth. This happens when stars run low on hydrogen fuel in their cores. The star then starts burning hydrogen in its outer layers, which makes it puff up like a cosmic balloon. The expanded surface cools down and glows with a distinct reddish color. That's why we call them red giants. These stars are super bright, shining hundreds of times more intensely than before, even though their surface is cooler. Betelgeuse in the constellation Orion is a famous red giant you can spot with your own eyes. Its reddish glow stands out clearly against the night sky. Blue supergiants are like the rebellious teenagers of the cosmos, young, energetic, and burning through their resources at an incredible rate. These massive stars are some of the hottest and brightest objects in our galaxy, shining with a striking blue-white light that can be seen from enormous distances. They're much bigger than our sun, typically 20 times more massive, and burn their fuel thousands of times faster. A great example is Rigel, the bright blue star in Orion's foot, which blazes at a scorching 21,000 degrees Fahrenheit. But like teenagers, this intense phase doesn't last long. Because they use up their fuel so quickly, blue supergiants only live for a few million years before dramatically ending their lives in powerful supernova explosions. Let's talk about one of the most fascinating stellar events in recent history, the Great Dimming of Betelgeuse. In late 2019, this famous red giant star suddenly started getting darker and changing color, causing quite a stir in the astronomy world. Scientists watched in amazement as Betelgeuse lost about two-thirds of its usual brightness, making it visibly different even to backyard stargazers. Many people wondered if this massive star was about to explode as a supernova. But the truth turned out to be less dramatic. Betelgeuse had basically sneezed. The star ejected a cloud of dust that temporarily blocked some of its light. By spring 2020, Betelgeuse returned to its normal brightness, giving astronomers valuable insights into how giant stars behave. Let's explore how temperature acts like a cosmic fashion designer for stars. When we look at a star's color, we're actually seeing how hot it is, just like how a blacksmith's metal changes color as it heats up. The coolest stars dress in red, glowing at around 5,000 degrees Fahrenheit. That's like a cosmic campfire. Medium-temperature stars like our sun prefer yellow outfits, showing off their 10,000-degree surface. The real fashion icons are the blue stars, strutting their stuff at a sizzling 40,000 degrees. This color-temperature connection helps astronomers understand stars without ever getting close to them. It's like having a thermal camera that works across the entire universe. The next time you look up at the night sky, remember you're seeing a grand fashion show where temperature determines every star's style. Let's explore one of space's most amazing partnerships, binary stars. These are pairs of stars that orbit each other like cosmic dance partners, and they create some truly spectacular light shows. When two stars get close enough, they can actually exchange material, causing their colors to shift and blend. Sometimes a blue star might pull gas from its red giant partner, creating a purple glow as the materials mix. In other cases, one star might completely cover its partner with transferred material, giving it a whole new appearance. The famous star system Algol shows this beautifully. Every few days, one star partially blocks the other, causing the system to dim and brighten like a celestial light show. Let's explore what happens when stars like our Sun reach their final stage of life. They become white dwarfs. These small but mighty stars are about the size of Earth but pack almost the same mass as our Sun. White dwarfs shine with a pure white light because they're incredibly hot, around 180,000 degrees Fahrenheit. But they're actually cooling down slowly, like embers from a dying fire. Over billions of years, they'll fade through different colors, first yellow, then red, and finally become cold, dark objects called black dwarfs. The nearest white dwarf to Earth is Sirius B, which orbits around Sirius A, the brightest star in our night sky. These stellar remnants help us understand how stars like our Sun will end their lives. Some stars put on an amazing light show by changing their brightness and color over time. We call these variable stars. Take Cepheid variables, for example. They pulse like cosmic heartbeats, getting brighter and dimmer in a regular pattern. As they pulse, they also shift from yellow to slightly redder colors and back again. These changes happen because the star actually gets bigger and smaller, like a balloon being inflated and deflated. RR Lyrae stars do something similar but faster. They complete their whole light show in less than a day. These stellar performances aren't just pretty to watch. They help astronomers measure distances in space. By timing how quickly these stars change, we can figure out how bright they really are, and therefore how far away they must be. Let's peek into our Sun's colorful future. Right now, our home star glows with a familiar yellow-white light, but that won't last forever. In about 5 billion years, the Sun will start running low on hydrogen fuel and begin its dramatic transformation. Its outer layers will expand dramatically, cooling down and shifting to a redder color as it becomes a red giant. During this phase, it'll be much brighter but cooler on its surface, kind of like a giant cosmic light bulb that's been dimmed but made huge. Eventually, after shedding its outer layers, the Sun will shrink down to become a white dwarf, glowing with an intense white light from its incredibly hot surface. This final chapter will last billions of years as it slowly cools and fades away. Taking pictures of stars isn't as simple as pointing a camera at the sky. Modern astronomers use special cameras and filters that can pick up colors our eyes can't even see. These cameras work like super-powered versions of your phone camera, collecting light for hours to reveal the true colors of distant stars. The images often need computer processing to show us what these stars really look like. For example, the Hubble Space Telescope uses different filters to capture specific wavelengths of light, which scientists then combine to create those stunning space photos we all love. Amateur astronomers can get amazing results too, using specialized cameras and telescopes in their backyards. They often take multiple photos through different colored filters and stack them together, revealing details that would be invisible to the naked eye. Thanks for joining us on this colorful journey through space. The stars above tell amazing stories through their changing colors. If you enjoyed learning about our cosmic light show, hit like, subscribe, and share this video with your fellow stargazers.